All right, now that you have gotten familiar with going from standard to slope-intercept form, or solving from standard to slope-intercept form, we're going to work on slope-intercept form. This will be page 35 in your binder. It says Liam has $10 in a savings account and plans to deposit an additional $5 each week. Liam wrote the equation and created the graph to show the relationship between X and the number of weeks and Y, the balance in his savings account. To find the slope of the graph, where do you see the slope in Liam's equation? Okay, well, let's find the slope of the graph. Because we do have a graph, the best method to use is rise over run. Make sure you draw your triangle above the line, not below. And because it is a graph, we're going to use rise over run. Okay. Now, a couple of things to keep in mind. Remember, you always want to check your units. So if we look at the x-axis, they're going by ones. That's no big deal there. If we look at the y-axis, those are going by fives. So we're rising by 5, 10, 15. And we're running 1, 2, 3. And 15 divided by 3 is 5. Where do you see that in this equation that they've given us? You see it in the coefficient. It is the coefficient of x. Okay. And it says, where does the graph intersect the y-axis? Intersect, where do they meet? Well, we can tell that they're meeting. Ooh, I'm going to get a different color actually. Maybe pink. This is your y-axis and this is the line. Where are they crossing? Where are they meeting? Right there at the number 10. Okay. And where do you see that in the equation? That would be the constant. So slope-intercept form, or also known as y is equal to mx plus b, is one way to write the equation of a linear relationship. Anything that deals with slope will always be linear. Anytime you get any kind of question about slope will always be linear. Okay? It's always going to be linear. Nothing different. Okay. So anyway, use the definition of slope-intercept form above to answer questions 1 through 4. Okay, well, if we look at this equation, it is already, first thing you want to check to see is if it is solved for y, if y is by itself already. And in this case, it is. So the slope should be easy to identify, and it always helps. It does help to write slope-intercept form right above it. That way you can notice, well, my slope is the coefficient, which is 2.5, and my y-intercept, b, is the constant, which is 4. Now, just for future reference, your y-intercept, they don't use it a whole lot with linear relationships, but they do use it. It's also known as the starting point. The lesson, a couple lessons ago, we talked about all of the words that can be used for slope. Well, for the y-intercept, they can use a starting point, the beginning, any kind of synonym that resembles the start. Okay. Next one. If I write y is equal to mx plus b, you will notice that there is something missing right here, correct? B is missing. What is one number that you can add to any equation and it does not affect anything at all? The number 0. So we'll see that the slope is negative 1 over 7. Remember, when I ask for the slope, I'm not asking for x. I'm only asking for the coefficient. And the y-intercept is 0. Next, we can clearly see that the y-intercept is negative 8. But for the slope, there's no number. Remember, you always fill it in with the 1. So slope is actually negative 1 in this case. Next, they want us to write an equation in slope-intercept form from each graph. So now we need to know how to find the slope and the y-intercept get that information from each graph, okay? So the first thing I'm gonna do, label my x and my y-axis and check my units. Always, always check your units. And in this case, these units are going by 2s. So make sure you are checking that. Okay. Now, I'm going to put a star next to B. And the reason for that is because that is the very first point I want to look for. That's typically the easiest point to look for. Where does the line cross the y-axis? Okay, my y-axis is always this vertical axis. Doesn't matter if it's at the very left side, if it's in a little bit moved to the side, or if it's in the very middle of the graph. It will always be your vertical axis, that vertical number line, okay? In this example, our line starts at 18. So we need to find another good point. So we need to find another good point. That way we can use rise over run to find the slope. Okay, we rise by 2, 4, 6, 8. And then since we are running to the left, running backwards, that makes this number negative. And 8 divided by negative 2 is negative 4. Now to write the equation, you want to write the equation in slope-intercept form, where the only numbers that will be substituted are here and here, okay? Substituted means replacing. So I'm going to replace m with the negative 4. I don't replace the x, and I replace b with the 18, but the 18 is positive, so we connect it with the plus sign. And there's the equation of this line. Y is equal to negative 4x plus 18. All of this information found from the graph. Number 6. The very first point that you want to look for is the y-intercept. This line is crossing the y-axis at the number 3. Okay. And we need another point in order to find the slope. This one's a good one. Draw your right triangle on top. We're going to use rise over run to calculate that slope. 1, 2, 3, 4, 5 going by ones. 1, 2, 3, 4, 5 going by ones. All right. So 1, 2, 3. We rose by 3. And we're running 1, 2 to the right. So that's a positive 2. 3 halves does not simplify. So when we substitute, the slope is the coefficient of x. B goes behind. Number 7. Always look for the y-intercept first. It's crossing at negative 2. And typically it gives you a good first point to use. I'm going to use this one here on the side. We're going to rise by 1. And we're running what? Backwards. So that makes this number negative. 1, 2, 3 boxes. This fraction does not simplify again. So y equals negative 1/3 x minus 2. Turn your page. In 8 through 10, you're going to plot the y-intercept, then use slope. This time we're going to go backwards. We're actually going to graph these lines. You're going to plot the y-intercept first, then you're going to use slope or rise over run to plot a second point on the graph. Draw the line connecting the points, create a graph, create the graph of the linear relationship. Well, very first place we look is find your y-intercept. And I should probably change colors for this. Find your y-intercept, okay? The y-intercept for this equation, I know you have to write small, is -4. So the very first point I'm going to put on my line is down here. Just like it is the first point you look for, that's going to be the very first point you plot. Now our slope is +2/3. Top number tells us how many to rise. Bottom number tells us if we're going to run to the left or if we're going to run to the right. And in this case, because it is positive, we're running to the right. So we're going to move up 2 boxes and to the right 3. So from this point here, we're going to go up 1, 2, to the right, 1, 2, 3. Notice how it's a 2 by 3 box right here. Go up 1, 2, to the right, 1, 2, 3. That one kind of goes off of the graph a little bit, but there is the graph of this line. Let's try this again. The very, very first point you want to graph is at 45. Oops, X and Y. Now notice this is going by 5s, okay? Now the slope is -5, but what happened here? We're talking about -5 is a whole number. To turn it into a fraction, we're going to put it under a 1. Now, because I cannot go up and to the left because of the negative, since I can't go up and to the left because of that negative, I'm typically, because of the negative, we're going to rise and we're going to run backwards, correct? Well, if I run backwards, I fall off the grid. So the opposite of going up would be down. The opposite of going to the left would be right. So we're going to go down 5 boxes, right 1. Down 5, right 1. Down 5, right 1. Down 5, right 1. And the reason I'm only going down 1 box, remember, is because we're counting by 5s. Down 5, right 1. But that ends up being that line. Make sure you draw it all the way through. Number 10. This one does not have a y-intercept, so that lets us know it's going to be right there in the middle. Look at both axes. Both axi are counting by 2s. 2, 4, 6, 2, 4, 6, right? So let's grab that slope. That slope is 1/2 positive. So we go up 1, right 2. Actually, it was supposed to be, well, dang. Sorry. This is a typo. This one is on me. It was supposed to be a -1/2. We're supposed to get a little bit more practice doing that. -1/2. Okay. We rise because of the negative. We run to the left. Okay. So we're going to rise 1, left 2. Rise 1, left 2 boxes, point. Rise 1, left 2 boxes, point. Because we ran out of room here, we can go the other direction. Opposite of up is down. Opposite of left is right. We can go down 1 box, right 2. Down 1, right 2. Down 1, right 2. And there is our line for that one. Graphing is something that we're going to do that we're not going to do a whole lot. So you will get some practice on it, but since everything is computerized on the STAR test, you'll be fine. For number 11, it says write the linear equation in slope-intercept form. This time we're not provided graphs, right? So in order for us to get the information that we need another method. When we don't have graphs, what do we use? No graph, we use slope formula, okay? So because we don't have slope formula written on this page, I'm going to go ahead and write it. You can also find it in your reference chart. I'm going to use this as x1, x2, y1, y2. All right, so at the top of the fraction, y2 minus y1, -3 minus -4.6. Minus -4.6. 0 minus -2. 0 minus -2. Don't forget that minus sign does not take the place of the negative. So we just type this in, minus -4.6. 0 minus -2. And that gives us 0.8. And believe it or not, you should be able to spot the y-intercept. What do we know about every y-intercept? In any y-intercept, the first number or the first point is 0 something. So in this case, our y-intercept is 0, -3. Okay, so now we have both numbers that we need. Y is equal to 0.8, x minus 3. Next, number 12. Let's find that slope. I'm just going to use the very first 2 points like the last one. Really does not matter which two you use, x1, x2. I do that. I've been doing that a lot. y1, y2. So to find the slope, 200 minus 35. 3 minus 0. Type that in. And we get 55. Your y-intercept, where do you find that 0? 0, 35. So your y-intercept is 35. Your equation, y is equal to 55x plus 35. In a real world situation, what would we do? Here we go. The graph shows the linear relationship between the number of minutes Ingrid has traveled and the number of miles she is from her work. Okay. Why would the miles be going down? Because she is getting closer to her destination. Okay. She is getting closer to her destination. So it says, what is the rate of change and what does it represent? When you see that word represent, they're wanting to know what it represents in words. Okay. They're wanting to know what it represents in words. So first, let's find that rate of change. Rate of change is another word for slope. And we do have a graph. We do have a graph. Since we do have that graph, we can use rise over run. But which point do we like to find first? We like to find the y-intercept first. So let's find that. Y-intercept is 24. So now we can use that information and find another point we can use, which is right here. Draw our right triangle. We rise by how many? They're counting by threes, so 3, 6, 9, 12. We rise by 12. We're running, but since we're running backwards or we're running to the left, that one's also counting by threes, 3, 6, 9. Our 9 is negative. Simplify any and every fraction So 12 over negative 9 gives us negative 4 over 3. But once again, why is it negative? We talked about this. It's negative because she is getting closer to her destination. She is on her way to work. So that means she is driving for what? Change in y over change in x. What does this 4 describe? 4 describes your y values. So for miles, we can use per, each, or every 3 minutes. Okay. Our slope is negative 4/3, but that means that she is driving 4 miles every 3 minutes. She is 4 miles closer to her destination every 3 minutes. Okay. Part B, what does the y-intercept represent? Well, I told you guys that another word for the y-intercept, right? The starting point, the beginning. So you want to include something that talks about the beginning, right? Well, when she is driving, she has traveled the number she is from her work. Let's just say she's leaving from home, right? She starts 24 miles away. She starts 24 miles away from work. So now that we have our y-intercept and we have our slope, we can write our equation. Y equals negative 4 over 3x plus 24. That 24 is still positive. When y is equal to 0, what is the value of x? Okay, so with every point, you have an x and a y. If y is 0, what is x? Well, y is 0 right here. So basically, they're asking us what is the x-intercept, which is 18. Let's think about it. Y represents what? Miles. 18 represents minutes. Why would it be 0 miles in 18 minutes? That means that she has made it to work. She has reached her destination. So she made it to work in 18 minutes. Okay. So now it's time for you guys to practice this on your own.